Hello everyone, hello Zimbabwe, hello Africa, India, China, Japan, all over the world. So let's continue with the repair things. It's on a Wednesday around 7 p.m. So we have these two boards. You can see two identical boards for HP. I don't know which model of this. They are exactly the same boards. So these boards came from another computer repair shop. So they said we have to fix one. But actually, we have this one which is on top with the charging port. What did they say? They said when you plug in the power around here, this chip, you see this chip is getting hot. So we have to diagonalize and see which board can be fixed easily. So that's the story with these boards. This chip, you see this chip, and what do I know about this chip? We have two coils, four MOSFETs, the driver. This is the 3.3 and 5 volts regulator and is getting very hot. So which board we can fix here? Let's check the first one, diode. Once we have to come to a conclusion which board we must fix here. The charging port on the current sensor is not shorted. On the last pin of the BIOS is not shorted. On those coils 3.3 and 5 volts looks fine. This looks fine. This looks fine. This looks fine. 270 ohms. What about this one? What about this one? Ohms. No, it's 26 ohms. Probably this is for the processor, which is fine. Okay. What about the other one? The other one, this coil is shorted. This one, yeah, this one has got two main faults. I can see this chip is blown up. This one is blown up. This one is blown up, and the last pin of the BIOS is shorted, and I believe this is the BIOS for the PCH. So I don't want to try this one. Probably we have a dead PCH. So let's focus on this one with the charging port. Let's focus on this one. What I will do, volts, I'll plug in the charger. You can see the charger is plugged. Volts. Let's check together. We have 19 before the MOSFETs on the DC in jack, 19.6. Before the MOSFETs, the first MOSFETs is a 19. On the current sensor, 19.6. On this power supply, 19. On this power supply, 19.6. On this power supply, 19.6. So our 19 volts power rail is present. What is the next step? The next step is try to see if the 3.3 is on, and here we have the connector for the power on button. For the power on button ribbon cable, we must have 3.3 there. First pin 0, second 0, third 0, fourth 0. So the 3.3 volts power rail is not present. Okay. Let's see this, the chip which was, yeah, this chip is getting warm. You know what? Let's clear this mistake by most of the technician. If you see, especially if you check the 19 volts is present and the 3.3 is not present at all, like in this situation. But let's check on the controller, on the capacitor around the ENE chip. We must have 3.3 there. What? $19. 0.18. So for sure, the 3.3 is not present. So the next step, you would see this chip is getting hot. Let me see. 1225C. You see this chip is getting hot. The next step, you think this chip is faulty, but I don't think so. Let's disconnect the power. Diode mode. Let's check. What I want to do, I want to check those capacitor around the ENE chip. This one is shorted. The second 0, the other side 0.0022. Like 3 capacitor shorted. So now you understand why that chip is getting hot, because we have a shorted EC chip. We'll see, but I believe this EC chip is gone. That's the reason why the 3.3 is not present. .24, around 2.7 amps. Can you go on a microscope so that we check together what's going on here? Let's go on a microscope, because someone has to see this. Check there. Check what the liquid is doing on top of the controller. You see? Liquid one more time. Maybe you can't see. Let's see one more time. I inject power. Check. I disconnect. The liquid is coming together. The liquid is separating. The liquid is coming together. The liquid is separating. The liquid is coming together. So for sure, we have a dead EC chip. That's an indication of a dead EC chip. In our case, it's an ENE microcontroller. So what I would do, where's the other board? Yeah, this chip is gone. On this one, that's the problem. On this one, I will check on same capacitors. I want to check on same capacitor, which I checked, and see how much current is taking. Probably 0.40. Yeah, this one looks good. So today we're gonna replace this we'll take out this ENE chip and we put it here. That's all what we have to do today. So let's replace this chip quickly. What is the first step is to take out this dead chip. That is the first step. Well, this chip is dead already. So we can come even with the 500 degrees, whatever. Yeah, that's the chip, which is gone. Now, the next step is to make sure that the whole area is clean. We have to make sure that the whole area is clean and everything is fine here. So what we need to do, let's take out this chip, the one which we want to replace, but now we need to come with the heat from the back. So I'll come with the heat from the back because we don't want to burn this chip. Very simple. Heat from the back. Yeah, the board is still sucking the heat. Simple. That's our chip. As simple as that. Now, the step that we want to do now, we have to go under microscope and start to cross-check few things. The place where we want to put the EC chip should be clean. We have like one ripped pad, but that's not a problem. That's not a problem. Actually, the pad looks fine. So we need to clean all those pads quickly. Or what I'm doing, I'm just cleaning all those pads. Let me clean and we'll try to replace together. Now, the hard thing is to align the chip properly. Or we can do this manual. Can do this manually. Let me put few pins. Let me solder a few pins and then we can do together. Let's do it now with what A. The other side. There's nothing hard here. Problem, the chip is too big. I can't fit it on microscope so that you see what I'm doing properly. Or either you can even do this off microscope. Let's resolder all those pins one by one, like beginner. We now need to do like beginner because we should make sure that all these pins, they are soldered properly. The last side, before we can test this. I think we're done. So, yeah, let's see now. Let's see now what this board is doing. We need to clean this. The problem, my microscope is not that great, so it's hard to show like the whole chip and a microscope. Let's plug in the charger. Check the light. We now have light. Okay, that's a good sign. That means our 3.3 volts power supply is now on and running. But let's see on those capacitors where we checked before. 3.3 you can see on the screen, and we checked here 3.3 and here 3.3. Let's check on the power button. First pin 0, second pin 3 volts, 3.28, 3.31. Let's try to power on this board quickly. First pin to ground. We have 4 pins here, so we'll try each and every pin to ground. Second pin to ground. And our board is on. You can see that light. So basically, that's how you can replace the microcontroller. Let's check some voltages on all the coils. This one 3.46, this one 5.18. What about this one? 1.36. This is the RAM voltage. This one 0.84. What about this one? 1 volts for the this one probably is the processor. This one the PCH here 1.84. This one is for the processor. This one might be for the GPU. And on the last pin of the BIOS 3.4. And here we have another coil 0.7, almost nearly 1 volt. Here 3.2. And our board is still on, you see. So that's how you replace this chip, the ENE. The 19 volts was present, but the 3.3 was missing because the ENE was shorted on the 3.3 volts power rail. So I'll stop this video now. Like, subscribe, don't forget to turn on the notification bell. See you on the next one. Bye.